Chapter 2.2, Day 2, Characteristics of Quadratics. So we're going to first start with practicing graphing. And so we're going to find the vertex, if it's a maximum or a minimum, axis of symmetry, and then we have to graph it. So we have y equals 6x squared minus 5. So we have to identify what type of form is this in. So is it in vertex form or is it in standard form? So remember that vertex form is y equals a times x minus h squared plus k. And then the standard form is y equals ax squared plus bx plus c. So it just depends on how you see it. Now looking at this, we have 6x squared minus 5. We are missing something here. So if you're thinking it's standard form, we can go with standard form. So we're missing a 0x. We don't have our b value here. So let's add that in the middle. So we can identify our a is 6, b is 0, and c is negative 5. So remember, to find the vertex, we use the x equals negative b over 2a. So we get 0, negative 0 over 2 times 6, which is just 0. Then, to find our y value of our vertex, we plug in this 0. So let's say f of 0 equals 6 times 0 squared minus 5. So 0 squared times 6 is 0. So 0 minus 5 equals negative 5. So our vertex is at 0, negative 5. 0, negative 5. And our axis of symmetry is x equals negative 5. So remember, you have to put x equals, not just negative 5. So our vertex is here. And so either we plug in a point, so I would plug in a point next to the vertex, or you can use the pattern. Our pattern is 1, 3, 5. And then we have to multiply the a value. So our a is 6. So you do that. So 6 times 1 is 6, 6 times 3 is 18, 6 times 5 is 30. So it's positive, it opens up. So therefore, from this point, from the vertex, we go right one up 6, and then reflect it across the axis of symmetry. And so here is our graph. Okay. Now, if your teacher requires you to plug in points, so again, you want to pick a point that's next to the vertex. So you can plug in 1 or negative 1. So let's just try positive 1, f of 1. So if we plug it in, we get 6 times 1 squared minus 5. So you square it first. That's 1, 6 times 1. So it's 6 minus 5, so it's 1. So you would get 1, positive 1, which is exactly what we got. And then you reflect it across the axis of symmetry. And so here is our graph. And actually, now that we're done, if you look at it, we can kind of look at this as vertex form a little bit. We can think about, how is this transformed? So if there is no b value in the center, like this one, there's no b, we have a squared and then we have our constant, then we can kind of look at it as just transformations. So let's just talk about transformations real quick. So how is it transformed? Well, we know that the 6 in the front means it's a vertical stretch by 6, and then the negative 5 at the back means that it went down 5, and that's exactly how this graph looks like. Okay, so just some key vocabulary terms just to remember terms. Our vertex form is f of x equals a times x minus h squared plus k. And so the axis of symmetry is x equals h. And we can read the vertex. So that's what's nice about vertex form. It's h, comma, k. Standard form, we have f of x equals ax squared plus bx plus c. And c is our y-intercept. Okay, we can read that immediately. Axis of symmetry, that takes a little bit more work. That is x equals negative b over 2a. We have to calculate the axis of symmetry. Then you find the vertex using that axis of symmetry, negative b over 2a, and then you plug it back into the original function to get your y value out. Remember that the axis of symmetry is the x value of the vertex. It also divides the parabola into mirror images. The vertex is a minima, so the lowest, when a is greater than 0, or when you know that it's positive in the front. Then we know that it's a maxima when it's open the other direction, when a is less than 0, or when it's a negative a in front. Okay, so that's it for the intro part of this. Next video we'll have graphing in intercept form.